Jupiter. The very name evokes a sense of power and grandeur. Jupiter is the king of our solar system, a colossal giant that dwarfs all other planets. Imagine a planet so large that it could hold over 1,300 Earths within its volume. But Jupiter is much more than just its size. It's a swirling vortex of color, a complex world with its own unique story to tell. Its swirling clouds, raging storms, and enigmatic Great Red Spot hint at the powerful forces at play beneath its surface. Jupiter is a gas giant, primarily composed of hydrogen and helium, much like the Sun. It lacks a solid surface like Earth. Instead, its atmosphere gradually transitions into a dense, swirling interior. Jupiter's immense gravity shapes the orbits of countless objects in its vicinity, shielding planets like Earth from cometary bombardment. Join me as we venture into the heart of our solar system and uncover the secrets of Jupiter, the king of planets. To understand Jupiter, we must journey back in time billions of years ago to the chaotic birth of our solar system. Imagine a swirling cloud of gas and dust, the remnants of a long-gone star. Gravity, the architect of the cosmos, slowly draws this cloud together. As the cloud collapses, it spins faster and faster, like a figure skater pulling in their arms. At the center of this maelstrom, the sun ignites, blazing into life. The sun's powerful radiation pushes away the remaining gas and dust. However, some material remains, swirling around the newborn star in a vast disk. Within this disk, tiny particles collide and stick together, growing larger over time. Jupiter, being the largest planet, formed early in this process, gobbling up vast amounts of hydrogen and helium. Had Jupiter been about 80 times more massive, it would have ignited into a star, forming a binary star system with our Sun. Jupiter's immensity is not its only impressive feature. Consider its rotation. A day on Jupiter lasts just under 10 hours. This rapid spin whips its atmosphere into a frenzy, creating powerful winds and swirling storms. While Jupiter spins rapidly on its axis, its journey around the Sun is a more leisurely affair. A year on Jupiter is equivalent to almost 12 Earth years. Jupiter's axial tilt is minimal, at just over 3 degrees, meaning it doesn't experience significant seasons like Earth. Instead, it maintains a relatively consistent climate throughout its year. Section 4. Beneath the clouds. Composition and structure. Peering beneath Jupiter's swirling clouds is like peeling back the layers of a cosmic onion. At its core, scientists believe Jupiter harbors a dense core, likely composed of heavier elements like rock and ice. This core is thought to be several times the mass of Earth, crushed under unimaginable pressure. Surrounding this core is a vast expanse of metallic hydrogen, created under immense pressure, acting like a liquid metal. It's this layer that's responsible for generating Jupiter's powerful magnetic field, stretching millions of kilometers into space. As we ascend through Jupiter's atmosphere, we encounter a layer of liquid hydrogen and helium churned by convection currents. Finally, we reach the layer we can actually see Jupiter's atmosphere. This is a dynamic and chaotic realm, dominated by swirling clouds of ammonia, water vapor, and other trace gases. These clouds, arranged into distinct bands and zones, give Jupiter its iconic striped appearance. Section 5. A celestial entourage, moons and rings. Jupiter is not a solitary giant. It's a celestial king, ruling over a vast retinue of moons. These moons, over 79 and counting, are a diverse collection of worlds, each with its own unique story to tell. Some are small, rocky bodies, likely captured asteroids. Others are icy worlds, their surfaces scarred by ancient impacts. And then there are the Galilean moons, 4 giant moons first observed by Galileo Galilei in the 17th century. Io, the innermost of the Galilean moons, is a volcanic world, its surface constantly reshaped by erupting volcanoes. Europa, the smallest of the 4, is an icy moon thought to harbor a vast subsurface ocean. Ganymede, the largest moon in our solar system, is even bigger than the planet Mercury. Section 6. Exploration and significance. Jupiter has long captivated the imagination of astronomers and scientists alike. From early telescopic observations to modern space missions, our understanding of this giant planet has grown tremendously. The Pioneer and Voyager missions provided the first close-up images, revealing Jupiter's complex atmosphere and its many moons. The Galileo orbiter and probe, launched in 1989, spent 8 years studying Jupiter and its major moons. More recently, the Juno mission, which arrived at Jupiter in 2016, has been uncovering new details about the planet's atmosphere, magnetic field, and interior structure. These missions have expanded our knowledge of Jupiter and provided insights into the formation and evolution of our solar system. By studying Jupiter, we learn more about the conditions that shaped the early solar system and the processes that govern planetary systems beyond our own